Okay, let's start today's session, and I'm going to share my screen. So I hope it is visible to all of you. Yeah, so today we will do, but actually we have already finished the nuclear and particle physics course the last Sunday, but also I have taken one extra class regarding the exam related questions and all, like what will be the suggestion for the exam and all. But today what we will do, as so many of you requested to take one more class on exam related suggestions and all, so that's why we are taking this class. In this class I will just overview again what will be the exam pattern and all, and after that I will take some like important questions what I am thinking that it can be an important question, or if you have any doubt you can obviously ask me in between the question lecture also. But yeah, like what will be the basically important thing as I am thinking. Okay, this we will discuss today, and one more thing we will discuss what will be the exam pattern, as I already discussed that one in last class also, but still I am going to discuss that one today again. So like if anyone missed that part, then he or she can see that video, so that it will be helpful for all of you. So first of all, what we will want to know, we will take some exam pattern first. So what will be the exam pattern here for 2023 Nuclear and Particle Physics course? So the exam pattern, if I write here, the exam pattern, like there will be total 100 marks. Okay. So as a whole there will be 100 marks, and among this 100 marks, each and every question has 2 marks. So as a whole, how many questions will be there? Obviously 50 questions will be there, right? So there will be total 50 questions, and among these 50 questions I can write it a little bit elaborately, that how many parts will be coming from which type of questions and all these things. So among these 50, first of all there will be a little bit division. Like division means there will be ten questions from basics. Basics means there will be very simple basic questions, and it will be obviously MSQ. MSQ is a multiple selection questions. That means there will be more than one or more than one correct option should be there in each and every questions. So that type of question should be 10, and these things will be very much basics, and it will come from the very basic knowledge of nuclear and particle physics. Okay. Now come to the next topic. Next topic will be 15 questions. 15 questions will come from assignments. This is also the type. The type will be also the MSQ type. So it will come directly from the assignments. Assignments from this. Assignments means this type, this year assignment as well as the previous year assignment. It can be included. Okay. So now there will be total 1, 10 and 15, that means 25 questions is already covered here. So first one is the basics from the nuclear particle physics course, and the second one is the coming from the assignment. Directly it is coming from the assignment questions. So as a whole there will be 25 questions from these things, and these two has the nature as MSQ. Okay. Now rest of the 25 questions, you can see that as a whole it was 50 questions, so that means 25 has already gone. So rest of the 25 questions will be there. Among these 25 questions, these all 25 questions will be little bit open and advanced. Okay, so open and advanced means like it can be little bit tricky questions, or it can be little bit beyond the scope of, beyond the assignment questions. Okay, not exactly beyond the course obviously, because whatever the question will be there, it should be included in the particular physics course, whatever shall taught. So, but among these 25 questions, I can just divide that one a little bit. Among these 25 questions, first of all, there will be 15 questions which are essay type. Essay type means short answer. Okay, and the rest of the 10 questions, these will be MSQ, multiple selection questions. So 15 questions will be short answer type questions, and 10 questions will be MSQ questions. And among the short answer type question, I can write it like any mathematics, that means numerical questions or analytical questions, something like that. And the 10 questions will be MSQ type questions. Okay, so this whole, that means you can see here that the first topic is very basic, that means it should not be that much problematic, and the second topic is also the assignment. It is coming directly from the assignment. If you see that assignment very clearly and rigorously, then you can have the like totally 30 marks you can got from that 15 questions, and from 10 questions, as it is very basic, you can also get 20 marks from these questions. So that means you can see here that as a whole 50 marks you can get very simply. The main important thing or main problematic thing is that rest of the 25 questions. I don't think that it is a very that much tricky or that much hard questions or complex questions, but yeah, like if it is a little bit open and tricky questions, then that will be little bit focused. That should be little bit focused, right? So there are 15 questions and there are 10 questions. So 15 questions will be short answer and 10 questions will be MSQ type. So if I do some type of little bit revision, that which are the topics or which are the chapters will be very much important, then I can write here like you can see here the relativistic nuclear physics. So relativistic nuclear physics means which relates the special theory of relativity. Special theory of relativity. This topic can be a little bit important for this case, and then the next will be like cell model, semi-empirical mass formula, then the next one can be write as like that nuclear reactions, possible nuclear reactions or not. That means there will be a state of, there will be some options for the nuclear reactions, and will it be allowed or not allowed, something like questions, that type of questions that should be there. And then Lorentz invariance, Lorentz and gauge invariance. Then radioactivity, then there will be oscillator, Van de Graaff generator, then cyclotron, etc. That type of questions can be there. That what will be the magnetic field, what will be the value of frequency, and all these questions should be there. Okay, so this type of important topics we can cover. So topics means I have already written here the special theory of relativity. Then the second one can be written as cell model, semi-empirical mass formula. Third one will be nuclear reactions, allowed or not allowed. Then fourth one will be Lorentz and gauge invariance. Fifth one can be radioactivity and their related questions. Sixth one can be written as oscillator, Van de Graaff generator, cyclotron, etc. Okay. So now what I have done here in that class, I have just little bit figure out some important topics, and among that important topics I have taken some important questions for you, so that it will be okay, so that it will be very much important for you and as well as helpful for you. Okay, so what are these questions I have taken here? The first questions can be written as the form momentum of a particle is 130, 0, py, pz. All the figures in MUIC units. Okay, the direction of its velocity is 4y cap, 3z cap. If the mass of the particle is 120 mv by c square, px and py and pz are how much? Okay, so they are asking that there is a form momentum as 130, 0, py, pz, and the direction of the velocity is given here, and the mass of the particle is also given here. So that means what will be the value of px, py, pz? So what we will do here, we will first of all write here. This type of questions are very common and very simple also. So we have to just think about the notation and all. So here you can see what is the notation here. This is P0, P1, P2, P3. So P0 is what? P0 is E by C. And then P1, P2, P3 means Px, Py, Pz. Right? So what we will do here, like first of all, in that question they have given that the mass is like 120 mv by c square, and E is given as 130. So now you can see there is a very simple expression that E square equals to P square plus C square. So P square plus M square. So P square means Px square plus Py square plus Pz square. And then there will be one M square, right? So if I just take P square in the left hand side, then it will be like E square minus M square. Now you can see here in the question the E is 130 and M is 120. So that means it will be 130 whole square minus 120 whole square. So if it is 130 whole square and 120 whole square, then what will be the value of P square here? Okay, so I have just taken here the calculator, and I am just going to write here again 130, this is 16900 minus 120 into 120. Now you can see that it is 2500. So now what will be the value of P here? P will be root over 2500, which is 50. Now we will focus on the 2p square down here. So p square means px square plus py square plus pz square. These as a whole can be written as 2500. Right? Now in that term, yes, here we can see that px is obviously taken as 0. Py and pz is non-zero, right? So that means in that question it is 0, then py square plus pz square equals to 2500. So we can have one expression that py square plus pz square is 2500. Okay, so now we will focus on the options here, like what will be the value of py and pz, so that it will give us 2500 as py square plus pz square. Right? So now you can see that it is 4 and 3. So 4 and 3 obviously it will not give the 2500 because 4 for 16 and it is 9. So that means it will give only 25, not 2500. Right? Now coming to the second option, 40 and 30. So 40 square plus 30 square. So what will be the answer? 40 square is 1600 plus 30 square is 900. So as a whole it will give us 2500 and 2500. So now you can see that whatever the condition is given, that we need the condition that 2500 is equals to py square plus pz square. It is coming from option number B. Now if you just take the other options also, 10 by 3, 10 by 4. So 10 by 3 means 100 by 9, then plus 100 by 16. It will not give 2500, right? 25000 it will not give. Similarly, 1 by 9 plus 1 by 16, because 1 by 3 is there and 1 by 4 is there. So as a whole it is also not giving 2500. So the correct answer will be B, Py equals to 40 MeV by C and Pz equals to 30 MeV by C. Okay, so that type of question can be there in any type of part 3, that means that open and tricky questions in that portion, that type of question can be there. Okay, so this is about the first question. Now I have just taken one more simple question, and it is nothing but about the theory basis question. That what will be the, if you have the very clear conception about the theory part of the nuclear and particle physics, like nuclear reaction, then it can be possible to answer. So what is the question here? Two particles A and B of same mass m1 and same kinetic energy T1 collide together, annihilate and produce another pair of particles C and D, each with kinetic energy T2 in the center of mass frame. Which of the following statements is or are correct? Okay, so what is the question here basically? In that question they are telling that our A and B is colliding and it is making C and D. First of all, the mass is m1, mass is m1. Kinetic energy T1, kinetic energy T1. This kinetic energy T2, T2. Okay. So, if I just put the energy conservation law, then what will be the energy conservation law? m1 plus T1 plus m1 plus T1. It should be equal to T2 plus T2 plus mass of C plus mass of D. Right? Now you can see here, if I just calculate a little bit, then it will be like 2m1 plus 2t1 equals to 2t2 plus mc plus md. So there are four options and we have to choose that which one or two is are the correct one. First of all, the reaction is energetically possible only if T1 is equal to T2. It is saying that T1 is equal to T2, at that condition only the equation is possible. But it is not correct. See, if I am taking that T1 is less than T2, at that condition, if T1 is less than T2, then also if M1 is greater than MC plus MD, at that condition also the expression and that reaction will be possible. Right? So, whatever the first option was there, that will not be correct one. Now coming to the second option. Both C and D have the same mass. Okay, so for that, let's assume that MC is equal to MD. Then what will be the answer here? 2T1 equals to 2T2 plus 2MC. Okay, so at that condition it should be correct one, because if it is not the same mass, then their the corresponding kinetic energy is also different. Because let's say if one mass is very heavy and one mass is very small, so their corresponding kinetic energy will also be different. So that at that time, the T2 and the kinetic energy of C particle and kinetic energy of D particle will not be the same one. So that means if its energy, kinetic energy are exactly same, so that means we can conclude that their masses are also exactly same. So that means the both C and D have the same mass. That is correct. If C1 is less than T2, sum of the masses of C and D is smaller than 2 into M1. Yes, that should be, because you can see, as I already told, if T1 and T2, among these two conditions, T1 and T1 is less than T2. So at that condition, this one should be greater than, the 2 into M1 should be greater than MC plus MD. 2 into M1 should be greater than MC plus MD. Otherwise, the energy conservation will not be satisfied. So the third option will also be correct. C and D cannot have the same mass. That is not correct, because we have already explained that both C and D have the same mass. Okay. So for that case, the correct answer will be B as well as C. Okay, so this is the second question, all about second questions. Now coming to the third question. In the third question I have taken gauge transformation equality, gauge invariance case. Okay, I have already mentioned as an important topic as gauge invariance. So if I write a gauge invariance question, then what will be the answer for this type of things? Okay, so what it is given here, our E vector is given as minus grad phi minus del A del T. Similarly, E prime is given as minus del phi prime minus del A prime del T. Now you can see that it is already given that there is a condition that E prime is equals to E, with phi prime is phi minus 2x. The new vector potential A prime is how much? Okay, first of all I am just trying to write all these expressions. Okay, then the condition is given as A prime equals to E, and one more thing is given which is phi. Phi is phi minus 2x. So first of all what we will do, it is the condition given in the question. Now first of all what we will do the grad phi prime, grad of phi minus 2x. So what will be the answer? Grad phi minus 2, right? Then if I just put this one in that expression, this expression, so what will be the answer? Minus grad phi prime minus del A prime del T equals to minus grad phi minus minus plus 2 minus del A prime del T. It should be equal to minus grad phi minus del A del T. Now you can see that if I just compare these two things, then you can see here minus del A prime del T plus 2 should be equals to minus del A del T, right? So del A prime del T minus 2 should be equals to del A del T. Del A prime del T should be equals to del A del T plus 2. Then A prime should be what? A plus 2T. And there is a gap. Like this is the direction. This is for the direction. So A prime should be A plus 2T x cap. Okay. So now if I just see the options here, A prime equals to A plus 2T x prime. This condition is correct one. Okay, because like there is minus 1 minus will be there and the plus is correct. So the option number B will be correct. All other options will not be the correct one. Okay. Okay, so this is the third question. I think third question. I think yes. So in that question, we are talking about binding energy. Binding energy of what? Like the atomic masses of magnesium and aluminium are this and this respectively. The Q factor of the beta process is how much? I have already mentioned very explicitly that what will be the value of Q factor if we have given the atomic masses or if we have given the nuclear masses. Okay, so I think I have explained that one in which video, I think week 6 or 7 video. Okay, so like when we were talking about the calculation of the Q factor, right? So in that question, the mass, atomic mass of magnesium 27 is given as this one. Atomic mass of aluminium 27 is given as this one. So what will be the Q factor of the beta process? So if it is a beta type interaction, that means magnesium is going to aluminium plus beta. In that type of nuclear reaction, the Q factor will be like atomic mass, like nuclear mass of magnesium minus nuclear mass of aluminium. Okay, minus mass of beta. Now if I talk about atomic mass, in atomic mass condition, the Q will be simply m of magnesium minus m of aluminium. How this m of beta will be cancelled out from that nuclear mass to atomic mass, then that one I have explained in the previous lectures also. You can go and check that lecture. So for that case, what will be the value of Q here? Magnesium was 26.98. 43 minus 26.91, 98154. 98154. As a whole, this will be in U unit, like atomic mass unit. So what will be the value for that? If I just calculate a little bit here, 9843 minus 26.98154. So this is an U unit. Now 00276. Now you can see that in our question it is given that up to 1 decimal plus you have to return the Q factor in MEV unit, right? So 1 U equals to 931.5 MeV. So if I calculate the similarities, then it will be in MeV unit 931.5 into 931.5. So what will be the value? 2.57. 2.57 MeV. So this will be the Q factor for this expression. Okay. So now coming to the next question. This is also very much equal to the Q value reaction of the reaction. Okay. So you can see here, this one decays to this to alpha emission. Atomic mass of this one and this one are this and this respectively. If the atomic mass of this one is alpha, what is the Q value of the reaction? And I have already written here that 1 equals 931.5 MeV. Now, previously we were talking about beta particle interaction. Now we are talking about alpha particle interaction. Emission. So what is the interaction here? FR 87200 plus, this is going as 80, 85, 196 plus alpha 24. Okay. So the Q is basically nuclear, I have already told that nuclear mass of FR minus nuclear mass of 80 minus nuclear mass of alpha. Obviously, alpha is a nucleus of helium, so that means there is no nuclear and atomic part different, and the nuclear part of alpha is exactly equal to the atomic part of alpha also. But now we have to take, as it is already given that atomic mass, it is not given as nuclear mass. So what we will do, we will just convert that nuclear mass to atomic mass, and we will put this expression so that we can have the value, right? So this is nuclear mass. Now atomic mass. So if I write here atomic mass, that means what? M of Fr 87,200. That means okay, 87 of M of E plus nuclear mass of Fr. Why? Because nuclear mass means atomic mass means nuclear mass as well as the electron mass. I mean, how many electrons are there in that atom. Similarly, mass of 80, then it is 85, 186. So 85, then 196. Now you can see I can write it like 85 Me plus nuclear mass of 80. So if I calculate Mn and all these things, then Mn of Fr is M of Fr minus 87 Me. M of 80 is Mn of 80 minus 85 Me. So what will be the Q value here? Mn of Fr minus Mn of 80 minus 87 Me plus 85 Me minus Mn of alpha. So it is nothing but sorry. Okay, this is Mn. This will be no N. There will be no N. M minus 87, M minus 85, and Mn. This one is exactly same. So this one. Okay. So here also there will be no N. 80 minus, you can see here, minus 87 plus 85. So 2 into Me minus M of alpha. So if I put these values, M of Fr is what? 200.00657. One 195.55979 579. And what is M of alpha? This is 4.0026032541 26032541 26032541. So what will be the Q here? Q will be, okay, so mass of E 0.511, MeV. So if I just convert it in U, then what will be the value? 0.511 divided by 931.5 U. Then what will be the Q here? Okay, so Q, these two, okay, I'm just going to write here 200.00657 minus 195.99579 minus 2 into 0.511 divided by 931.5 minus 4.002603254.1. This one will be in which unit? This one will be in U unit. Now we will convert it in MeV. So 931.5. 6.5947. So 6.5947, it can be written as 7 MeV. So the Q value will be of the order of 7 MeV. Right? So what will be the answer for that? The Q value will be 7 MeV. Okay, now coming to the next question. Radium-203 undergoes alpha decay with half-life of 4 milliseconds. At time t equals to 0, pure sample of radium-203 is taken with N0 atoms. If 3125 radium-203 atoms remain in the sample after 20 milliseconds, what is the value of N0? So this is coming from the radioactive term, like radioactive type questions. Okay. So what will be the answer here? First of all, they are asking that radium-203. It will decay. And whatever it is given here, that it is undergoes alpha decay with a half-life of atom. So T half is 4 millisecond. Now again what it is given, that 3125 atoms are remaining after 20 milliseconds. 3125 can be written as in 20 milliseconds. So from the radioactive expression, we have n equals to n0 e to the power minus lambda into t. And what is t here? T is 20 milliseconds. Then we can see that lambda we need to calculate. So lambda will be what? We have t half is 4. Lambda will be ln2 divided by t half. So that means ln2 divided by 4. ln2. Okay. So ln2 means what? 0. Okay. Let me do one thing. ln2 0.693. You can see here 0.693. 693 divided by 4. So what will be the value of lambda here? This divided by 4 is 0.1743. 1732. 1732. This is lambda. Now our n is given as 3125. So what we will do? 3125 equals to n0 e to the power minus lambda is 0.1732 into 20. So N0 will be what? N0 will be 3125 e to the power 0.1732 into 20. So this one into 20, this is 3.465. 3125 e to the power 3.465 or something. Now e to the power answer. E to the power 3 point, what was 3.4657, this into 3125. Okay, now you can see here the answer 29439.8. This is like 2943439, so that means 440 we can write it like that. So then our answer can be write as, what is the answer? 2.2943440, 29440, something of that range. Okay, so what we have done here, we have just taken a simple expression that n equals to n0 e to the power minus lambda t, and t we have taken as 20 millisecond, and from lambda I have taken ln2 divided by t half. ln2 is 0.693 divided by 4, then it will come as 0.1732, and it will be multiplied by 20, then it will be like 3.465 e to the power this one, and then e to the power, let me check, e to the power 3.46, 31, this one will be the correct one, 3125. Okay, so this is 99428, 428, okay. This will be 99428. Okay, now this will be the N0 value. Okay, I hope it's understandable. Now we will go to the next question. When a proton, mass taken as 1.67 into 10 to the power minus 27 kg, is accelerated using a cyclotron with magnetic field of 1 Tesla, the frequency of electric field between the T's should be what? In terms of 10 to the power 6 Hz. Okay. So in that question I have already given the important topic as cyclotron, accelerator, the nanogram generator and all. So that type of question can also be appeared. So what is the question here? The mass of proton is 1.67 into 10 to the power minus 27 kg. Then magnetic field is 1 Tesla. Magnetic field is 1 Tesla. So what will be the value of frequency here? So how to do that? Obviously most of the time we forget the expression for the frequency or the time period. So what we will do, we will just quickly produce or derive that expression so that it will be helpful for us. Obviously we will know that mv square by r equal to qvp inside the cyclotron case, right? So from that we can write mv divided by r equals to qb. Now what will be the b here? B will be qbr divided by m. That will be the expression for velocity. Now again b can be written as 2 pi r divided by t, which is nothing but b 2 pi r into f, frequency. So this one and this one can be equated to qbr by m, 2 pi r into f. So what will be f here? You can see that r and r will cancel out. So F will be QB by 2 pi m. Now in that question, B is given as 1 Tesla, Q is proton charge, that means 1.6 into 10 to the power minus 19 coulomb. Mass of proton is 1.67 into 10 to the power minus 27 kg. So if I put these values, then what will be the answer for F? F is 2 pi r, QB by 2 pi m. QB by 2 pi m. So 1.6 into 10 to the power minus 19 into 1 divided by 2 pi into 1.67 into 10 to the power minus 27. Now what we will do? We will simply do the calculation. 1.6 divided by 2 pi into 1.67. Then you can see here minus 19 plus 27. So what it will be? It will be 10 to the power 8. So if I calculate the answer here, 1.6 divided by 2 into pi into 1.67, sorry, 67, 0.1524. 0.1524 into 10 to the power 8. Now you can see here 15.24 into 10 to the power 6. This is in hertz unit. So the frequency will be 15.24 megahertz. Right? So our answer will be here 15.26. Okay? Because it is given as something into 10 to the power 6 hertz. So that will be the final answer. So up to that I have explained a little bit questions. I have explained today 1, 2, 3, 4, 5, 6, 7 questions. I have explained 7 questions, as well as I have just explained a little bit more on the exam pattern, and as well as how many topics will be important and which are these. Okay, so I hope this type of questions, whatever I have taken here as an important one, that will be helpful for you, as well as I hope that type of topic, whatever I choose here for the important one. If you just read these topics, as well as also you have to read other topics also with equal focus, but there will be a little bit more focus on these 6 chapters. That will be helpful for you also. And yeah, that is the thing. I hope all the questions will be answerable by all of you. So very all the best to all of you for your exam of the Nuclear and Particle Physics course NPTEL 2023, and the exam will be on 29th October. I think all of you have already got the admit card, or if you don't have the admit card, then within 1 or 2 days you can get this. And I'm going to record that lecture so that you will see that one after the lecture, or after the live lecture also. I'm going to upload this one in YouTube in my channel, and I'm also going to share this PPT whatever I have made today with that Google Drive option, and that will be helpful for you also. Okay, so yeah, till now, if there is any other question you can ask, or we will stop today's session. And all the very best for your exam. Okay, so yeah, these things are the questions. 50 marks Among 10 questions will be basics, 15 questions will be assignment type. Next 15 questions, among these next next 25 questions, 15 questions will be short answer and 10 questions will be MSQ, multiple selection questions. And these are the important topics we can take: relativistic nuclear physics, special theory of relativity, cell model, semi-empirical mass formula, nuclear reaction, allowed or disallowed, Lorentz and Gauge invariance, radioactivity, accelerator, Van de Graaff generator, and cyclotron. And I have taken a little bit more questions on this important topic, nuclear particle physics. So if you don't have any question, then we can stop, or if you have any question, you can ask me right now. We will meet. No. This semester we will not meet, and maybe in the next semester we will meet with the same course, nuclear particle physics. Okay, so till now, a very happy and enjoyable Durga Puja, as well as all the very best for your exam. Okay, so till then, bye bye.